So our lesson is on composite functions. Can you start us off, please?
Evaluating a function means to find the y value for a given x value.
So we did this back in grade 10 math. We learned how to evaluate functions. So if I give you f of x equals 4x plus 1, that's functional notation. We did learn how to do that back in grade 10 math. Now I can give you any value. So in the example, I asked you to evaluate for f of 1. So f of 1 means you replace all of your x values with 1. So Jillian, continue. 4 times 1 is? 4 plus 1 is? So f of 1 is equal to 5. So that's called evaluating a function. We did learn how to do that back in grade 10 math. Okay, so that's not today's lesson. That's evaluating functions. But today we're going to learn how to do something called composite functions. So this is a brand new concept. So Danny, what's a composite function?
When the range of one function becomes the domain of another function. For the two functions f of x and g of x, we can have the composite functions.
Yeah, f of g of x.
F of g of x written.
It looks like fog. That's just f open dot g. And we can also have
And g of f of x written as
g o f. Okay, so we can do both ways. We can have f of g of x. We can have g of f of x. We can also have f of x and g of x. It's not hard, but it's a little confusing. So I highly recommend having nice, neat, organized work so that you can tell what goes where. So for our first example, our f function, f of x is equal to x plus 1, and our g function is x squared. So the first example, Matthew, we're asking to solve for?
F of x squared?
After the equations, the first thing we want to solve is f of g of x.
F of g of x.
Okay, so now to solve for these, you always work from the inside out. F of g of x means you're taking the g function and sticking it into the f one. And again, don't write this down yet. Let's just do it once and then you can write it down. So we're putting the g function into the f function. Owen, what's the f function? The f function is, or the whole f function is, so don't write this down yet. The f function is x plus 1, but we're putting the g function into the f of function. Owen, what's the g function? So wherever you have an x in f, you stick the g into where there's an x in the f, if that makes sense. So you're taking your g function and you're inserting it into the f function. So when I insert that, I replace, you don't have to change the colors, and that's our final one. That's how you do f of g of x. It's not hard, but it's confusing. You're taking the g function and sticking it into the f. So I took the g function, and wherever I had an x value, I replace that with the g function. And I'm done. That's how you do f of g of x. Let's do the reverse. And I think in the notes I had, that's kind of a weird notation I have in there. I like what I did on the board now better. So the next one, we're going to do g, ooh, that's not the color I wanted. We're going to do g of f of x. So it's the same two starting functions. I'm just going to erase this. But again, we work from the inside out. We are now putting the f function into the g function. So Ben, what's the g function? X squared. Again, don't write this down yet. The g function is x squared. Now I'm putting the f function into the g function. So wherever I have an x, I replace it with the whole f function. So I replace the x with, what do I replace it with? X plus 1. Now technically I can leave it as x plus 1 squared, but on a multiple choice test and on the provincial exam, they'd expect you to expand it. Hopefully we know it's x squared plus x plus 1. That's just multiplying polynomials from grade 10. Okay, it's not hard, but like I said, it's kind of confusing. So just have clear, organized work so you know which way you're going. Yes? Oh, it is 2x, yes. X squared plus 2x plus 1. Thank you. Okay, so it takes practice. Once you do a couple, it's easy. It just seems more confusing than it is. Example 2, we're doing the same thing, but instead of x's, we're trying to replace it with numbers. So,
Oh,
can I clear the screen? And actually, can you read the screen probably better than the whiteboard, right? So for future, I might try and do the team calls maybe through my phone, because I think this might actually be easier than trying to use that board that no one can see. Okay, so example 2, what's our f function, Gerald? What's the f function for example 2? And what's the g function? Okay, so we're doing the same thing, but now we're going to put numbers instead of letters. So the first one, Gerald, what's the question? We're going to evaluate f of g of 2. I'm going to break it down into 2 steps so I don't get communication errors. So you always start from the inside out. So first we solve for g of 2. You always work your way inside out. Now again, don't write this down yet, but Riley, what's the g function? Okay, right now I have a communication error. You can't have numbers on the left and letters on the right. But I just want to show that's the g function. But I replace all the x's with what number, Riley? I replace all the x's with? Good, we're solving for g of 2. So this is like grade 10 math evaluating a function. Keep going, Riley. 2 squared is 4 minus 4 is 0. Okay, but that's not the question asked. We solved for f of g of 2. G of 2 is 0. Now, the question asked for f of g of 2, but I just said that f of g of 2 is equal to 0. So here's part 2 of the question. So first you solve for g of 2. G of 2 was 0, so now I solve for f of 0. Victor, what's the f function? But I can't have an x there, Victor. I have to replace the x with what number? Good. So Victor, 0 minus 2 is? Good. So what just happened? F of g of 2, what's the final answer? There's a lot of numbers on the board. What's the final answer here? -2. Good. Okay, so these are nice, easy 1-mark questions on your test and on the exam. But they're almost so easy that I think people don't study them as much because they think, oh, that's easy. But it can get confusing. Okay, still on example 2, but that was f of g of 2. What are we going to do in question B, Joey? We're going to solve for? So let's try it the other way. I'm actually going to erase this so I can keep the original functions on the board. I don't know what would have been faster. Maybe it's faster the other way. Okay, so it's still the same 2 starting functions, the same f and g function. But now, sorry, Joey, what was it? We're now solving for g of f of 2? Is that what it is? Okay, now I'm going to break it up. The first thing I'm going to solve for is step 1, I solve for f of 2. You always work from the inside out. Chris, what's the f function?
X minus 2.
But I replace the x with?
2.
Chris, what's 2 minus 2?
0.
So f of 2 is 0. Now, Brian, what do I solve for? I now solve for g of 0. So I just figured out that f of 2 equals 0, so now it's g of 0. Brian, what's the g function?
X squared minus 1.
But now I replace the x's with what number? 0. Good. 0 squared, Brian, is 0 minus 4.
You get 4.
Okay, so what happened? That's a lot of numbers. What did we just solve for? G of f of 2 is equal to, what's the answer? -4. Okay, so these are easy. Sometimes you do it with equations like in example 1. Sometimes you do it with numbers as in example 2. Okay, here's a fun little thing. Inverse functions. We just learned inverse functions last week. Composites are connected to inverse. So Nicholas, what's the little note about inverse functions?
No, inverse functions. The inverse function undoes the original function. To test algebraically, if f of x and g of x are inverses of each other, since f of g of x equals x and g, f of x equals x.
Okay, that's a lot of terms. What did any of that mean? So, are these inverses? You can tell right away the answer is, I purposely picked an easy one. Are they inverses of each other? What's the inverse of addition? Subtraction. So yes, but we have to prove it. So we'd have to show that. So according to what we read, let's solve for f of g of x first. So this is exactly back to example 1. So you put the g function into the f function. So we're back to the beginning. Jillian, what's the f function? But I replace the x with, what do I replace the x with? I replace the x with the entire g function. So that x, it gets replaced with, so you literally put the entire g function into wherever you had an x in the f. Jillian, what's 2 minus 2 plus 2? Minus 2 plus 2. So that just gives us x. So f of g of x equals x. Have we proved that they're inverses? No, we have to show, what do we have to show? We just showed that f of g of x is x, but we also have to show that g of f of x is also x. So now we're putting the f function into the g function. Danny, what's the g function? X minus 2. That's the g function. But now I put the f function where there was an x. I replace that x with x minus, oh, what am I? Sorry, the g function. Yeah, so now I replace, what's the f function?
G x minus 2.
Oh, I can't get there. Okay, the g function is x minus 2, but I replace the x with f. So what's the f function, Danny? X plus 2. 2 minus 2 is 0, so that leaves us x. So are these inverses? Yes. So this was an exam question once. Why are they inverses? Because we have showed that f of g of x equals x, and we also show that g of f of x equals x. So that's how you would prove it. Now, I'm going to stop the tape.